Going to our next page here. So what is the action of our antibodies? So our antibodies can do a couple of things. They can directly attach to the foreign antigen-bearing cell. So they can do a direct attack, basically, where they combine with the antigen. They cause agglutination. Remember when we were talking about blood and different things, agglutination is just that clumping of the cells up together, and it's basically going to form a substance that a macrophage would recognize. But they also can form insoluble substances. And then the other action that antibodies can do is they can create an activating complement. So this is a group of inactive enzymes, and they're going to produce a variety of effects. They can produce chemotaxis, opsonization, lysis, and inflammation. We talked about inflammation being non-specific immunity. So a little more info about each of those. Chemotaxis is where the activating complement, or the protein that is being produced by the antibody, will cause macrophages and neutrophils to come to the region. So it's just sending out a chemical smoke signal, basically. Opsonization is where the antigen-antibody complex gets kind of coated, and so thus doesn't work any longer, so it's gotten rid of. Lysis is, just the rupturing of the cell membrane of that foreign cell. Inflammation, we know, brings more white blood cells to the area. So those are created by an activating complement. It's a pretty kind of complex process of getting that going. So how are T cells activated? So we talked about B cells and the activation of our B cells, and our T cells are pretty important too. And how they get activated is that they, and actually the T cell being activated will help to activate the B cells. So our T cells are activated when a pathogen or an antigen-bearing agent enters the cell. And a macrophage or other cell, accessory cell, will phagocytize that antigen-bearing agent. And the lysozymes that are found within that cell will then digest it. And then it does something kind of interesting. It takes part of that protein or part of that polysaccharide or part of that glycolipid, and it displays them on the surface membrane of the accessory cell. So just kind of think of this as like the olden times where they'd put the heads outside the castle wall, or take the scalps of the people that they killed and wear them on their belt. So it's kind of like just displaying, here I've conquered this thing, and here's an example of it. So it displays those on the surface membrane of the accessory cell. Oops. And so that's a macrophage, or another phagocytic cell. Then along come T helper cells, and a T helper cell gets activated when encountering a displayed antigen that fits its receptor. So it finds its puzzle piece, it says, hey, I know that, or look, that scalp is the same color as my girlfriend. I don't know, that's kind of gross. But so it encounters that displayed antigen, and it then releases lymphokines. And lymphokines are just a chemical that it's going to put out. when it encounters a B cell. So here's how our B cells are going to help out our T cells are going to help out our B cells. That is previously combined with an identical antigen-bearing agent. So here's the story. So, T cell hooks up with this antigen-bearing agent, recognizes it, say, hey, I know triangles, and it cruises around kind of looking for another cell that perhaps knows triangles. So the T cell and the B cell, they get together, they say, hey, I know triangles too, and then that B cell is then, or that T cell is then going to help stimulate that B cell to make more of itself. So that activated T cell releasing its lymphokines, the lymphokines, show you a picture in a sec, stimulate the B cells to proliferate.